Waki.
Ay, Waki! Submit mo! Today we're going to do the laboratory experiment number 9, designing and making of concrete cylinder samples with SLUMP test. For the objectives, to design concrete cylinder samples, to calculate the concrete mix cement ratio and shrinkage characteristics for the cylinder, to evaluate the concrete workability for the sample using the SLUMP test.
For the materials and the laboratory equipment, we will be using the concrete mix, tamping rod, a slump cylinder, rectangular container, a shovel, a ruler, rubber mallet, trowel, digital weighing scale, a mixing pan, and a slump apparatus.
Containers of financing. Ay, listen mo eh.
Basa ka. Oh, yabay na yun.
Take the concrete out of the mold after 24 hours.
Go.
So now place the cylinders in the curing station.
Curing station.
Ay, okay, right. Piling ba di una maugang expose?
The experiment focused on designing and producing concrete cylinder samples while ensuring accurate material proportions and proper mixing techniques. A 10% volume allowance was incorporated to account for potential material losses and shrinkage. Additionally, for batch 2, the height was adjusted to 15 centimeters in the volume calculation, as batch 1 only filled approximately 2.5 containers of the cylinder mold, necessitating half a volume adjustment for consistency. The computed material requirements for batch 1 included 5.71 kilograms of cement, 2 containers of fine aggregate, and 3 containers of coarse aggregate, and 3.3 liters of water. While batch 2 required 1.2 kilograms of cement, 0.5 containers of fine aggregate, 0.6 containers of coarse aggregate, and 0.7 liters of water. The water content adhered to the 0.58 water-cement ratio from DPWH Blue Book, ensuring compliance with construction standards. However, challenges arose during the mixing and molding process, particularly in achieving uniform consistency and eliminating air pockets, uneven surfaces, and visible air voids were observed, likely due to insufficient rodding and tapping, which could contribute to honeycombing and reduce durability of the concrete samples. The SLUMP test result of 3.8 inches in accordance with ASTM C143 confirmed that the concrete mix achieved an acceptable balance of workability and consistency, without excessive stiffness and fluidity. Despite this, slight variations in consolidations may have affected the uniformity of the samples. To improve the mix, a material engineer should adjust the water content within ASTM C192 guidelines or incorporate a super plasticizer to enhance flowability without increasing the water-cement ratio. Proper consolidation techniques such as systematic rodding and tapping are also recommended to minimize air voids and ensure uniform material distribution. Additionally, the calculated shrinkage factor of 1.25 emphasized the importance of considering volume reduction during drying to prevent cracking and structural instability. This experiment reinforced the significance of precise measurements, effective consolidation methods, and proper curing conditions in ensuring high-quality, durable concrete suitable for structural applications. The experiment successfully demonstrated the design and production of concrete cylinder samples using the class ratio of 1:1.3 to 2 mix ratio, ensuring proper workability, strength, and durability in line with the ASTM standards.